The topic of this lecture is matrix of linear transformation. We'll cover these points in this lecture: matrix of linear transformation definition, example number 1, example number 2, and example number 3. So let us see what is the mean by matrix of linear transformation. Uh, let V is a linear space or vector space with dimension n. So its basis, say B, contains an element like this, and W is another linear space or vector space with dimension m. So its basis, say B dash, contains m elements. So these two are vector space we are having, V and W. And let us say T is a linear transformation from V to W. So let us take T as a linear transformation from V to W. Now each element Tuj will belongs to W. That is Tu1, Tu2, all elements will belongs to W. And W has this as a basis. So every element Tuj can be written like this as a linear combination of these vectors V1, V2, Vm. In particular, so Tu1 will be written as a alpha 11, alpha 21, alpha I1, alpha M1. Tu2 will be written as alpha 12, alpha 22, alpha I2, alpha M2. Like this way all these vectors are written. Note these coefficients. This coefficient is alpha 11, this is alpha 21, this is alpha I1, this is alpha M1. When we'll write the matrix of this, we'll write these coefficient as a column. So we'll write first as a A11, we'll write second as a A21, and last one will come as a AM1. And like this way all this vector will come, and the last vector will come as a A1n, A2n, and the last one, what will be this? That will be AMN. So simply we'll have to write these coefficients of these vector as a column vector, and we'll get the matrix like this. So you will find the matrix like this. This is the coefficient of first vector. This is the coefficient of second vector. This is corresponding to coefficient of vector Tu1. This is corresponding to vector Tu2, like this way. So all this will be written as a column. So it is called matrix corresponding to linear transformation T. It will be clear with the example. Find the matrix of linear transformation T from R3 to R2 given by, this is the definition given, with respect to standard basis of R3 and R2. So what is the standard basis of R3? The standard basis of R3 is 100, 010, and 001. And standard basis of R2 is 10 and 01. So accordingly, as the definition, we will take the first vector T11 and find its T image. So according to this definition, here the value of x is 0, the value of y is, the value of x is 1, value of y is 0, and value of z is equal to 0. So accordingly, this value when we'll put over here, we'll get 1 comma 2, because this will give us 1, and from this we'll get as a 2. So this 2 value will come 1 comma 2, and this 1 comma 2 can be clearly written as 1 into 10 and 2 into 01 as a linear combination of these vectors. Similarly for T01, here what is the value of x? The value of x is 0. Value of y is 1. Value of z is equal to 0. And Txyz becomes this. So T image of 0, 1, 0 will become, according to this definition, it will become, because x is 0, y is 1, and z is 0. So first we will get 2, and here x is 0, y is 1, and z is 0 according to this definition. So we'll get 2 comma 3. And when we'll get 2 comma 3, it can be simply written as a 2 into 1 comma 0, 3 into 0 comma 1. Similarly, for this third vector, we will find its image, that will be 2 comma 4, and that will be written as 2 into 1 0 and 4 into 0 1. And as I told you, these coefficients will write as a column of the matrix. So first column will become 1 comma 2, second column will become 2 comma 3, and the third column will become 2 comma 4. So we'll get this matrix of linear transformation, which is written over here. So it's very simple. Let us quickly see this example. Again, find the matrix of linear transformation from R3 to R3 given by this. This is the definition. X, Y, Z goes to this definition. This is first coordinate. This is second coordinate. This will be the third coordinate. And whenever its basis is not given, we'll take standard basis. And because it is from R3 to R3, we'll take this is the basis. So let us take the first vector T1, 0, 0. Here the value of X is 1. The value of Y is 0 and value of Z is equal to 0. So what will be the image of T1, 0, 0? That will be, according to this definition, wherever X is coming, so it will become minus 1. Here it will become 1 and Y and Z are 0, and the third coordinate will become 2. So simply this is minus 1, 1, 2, which is written over here. So this will be the image of this, and simply we'll write this as a minus 1 into first, 1 into second, and 2 into third. So we'll write in the linear combination of these vectors. Same way we'll do for the second vector, same way we'll do for the third vector, and we'll get the coefficients. And as I told you, we'll write the coefficient as a column. So the first column will become minus 1, 1, 2, that is written over here. Second column will become minus 1, minus 4, minus 5, that is written over here. And third will become 1, 1, 0, that is written over here. So this is simply the matrix of linear transformation. Now let us see the third case, third example. Let us see. For the linear transformation T R3 to R2 given by this definition, find matrix A of T with respect to basis. Here the B1 is this basis and B2 is this basis. So here the standard basis are not given. For R3, the basis is given as a B1. And what are the vectors of this basis? It is given over here. And what is for the R2, the basis given as a B2. It is not a standard basis. Its the vectors are given over here. But method will be same. We will find the images of these vectors in terms of T. So T image of 1, 1, 1 according to this definition. Because what is the value of X? X is equal to 1, Y is equal to 1, and Z is equal to 1. So when we will put these values as a T 1, 1, 1 in this definition, we will find that here the first will become 2 and the third it will become 5, because this will give us second coordinate will give us 3 minus 2 plus 4, so it will be 5. So this comes. Now our task is this 2, 5 will have to write as a linear combination of these two vectors 1, 3 and 1, 4. At present we don't know what will be the coefficient of this. So we are writing this as a into first vector and B into second vector, and we'll solve simply this equation. So what will the equation will become? This will become from this A plus B is equal to 2, and second equation will become 3A plus 4B is equal to 5. This is 3, which is written over here. And simply we'll solve these equations, and these are very easy to solve. We'll find the value of A is equal to 3 and B is equal to minus 1. So we'll put these values over here. So ultimately we'll get T1, 1, 1 as a, because the value of A is 3. So 3 times 1 comma 3 plus minus 1 times 1 comma 4. So here the coefficient will be 3 and minus 1, 3 and minus 1. So whenever the matrix will become, so the first column will become 3 comma 3 minus 1. This will be the first column. Same way we'll do for this vector and this vector. The same procedure will apply, and we'll find the values and we'll make the second and third column. So let us see for the second. Similarly, the T110, that will become 31, and again the putting value are like this, and solving this very easily will get 11 and minus 8. So these are the coefficients. So this will become the second column, 11 minus 8. So this will become second column. And let us see the third one, T100, that will become 23. Its coefficient will write like this, and again we'll solve, we'll get the value as a 5 and minus 3. So 5 and minus 3 become the third column. So matrix will become 3 minus 1, that is the first one, 11 minus 8, and the last one is 5 minus 3. So like this way this matrix is formed. Thank you very much. You can find the link of this PPT in the description box. Thank you very much.